Alright, so today we're going to keep talking about our basic notions of geometry. We looked at points, lines, and planes and identified them. Now we're going to look at specific parts of those things. We're going to start with lines. These notes are posted on Schoology, but you're going to notice that they're kind of blank. You could do a couple of things. You could print them off if you want and kind of fill them in as you go along. I also am planning on having a little kind of activity as you're going along. You can answer some fill in the blank, true, false, multiple choice questions as you're watching this video, just so you can kind of keep up with all of these different things. So what are we going to talk about today? We're going to look at things called line segments. We're going to look at the idea of measure and the ruler postulate. And then we're going to look at how do segments relate. We're going to look at this relation of congruent segments. When we talk about a point is between other points, what does that actually mean? So the notion of betweenness. And then in practical terms, we are going to figure out how do we find the distance between 2 points, whether those 2 points are on a number line or they're in the Cartesian plane, named after this guy Rene Descartes. We also call that the XY plane. So anytime you hear Cartesian, you can also say XY plane. Same thing. Alright, so let's start off with segments. What are they? How do we use them? How do we kind of differentiate them? So we looked at lines last time. We said lines are a set of points that go in opposite directions. So line segments are going to look kind of like this. They have a beginning and an end. So the difference between a line segment and a line is a segment is a finite portion of your line. So it doesn't keep going on forever. It has two endpoints. We're going to say endpoints. You can think of one as beginning and one as end. It doesn't really matter. But your typical segment will look kind of like this. You're not going to have arrows at the end. I know it sounds kind of silly. What's the difference between putting the arrows and not putting? Well, the arrows say that you keep going on forever, so that would be a line. This would be a segment. So I'm going to put some points there about W and R. So this is a line segment that has the endpoints at W and R. Last time we named lines, so now we want to name a segment. So this segment, we're going to use the endpoints, and instead of putting that line symbol, you can probably guess we're going to put a segment symbol. Now I know that seems kind of silly, not to, or I should say to have a different kind of object just based on two little arrows, but it's really important that we get that down. This is not the same as describing the line, so not the same as line WR. Line WR goes on forever. Segment WR is just a finite portion of that line. In fact, every segment is part of a much larger line. And you can have all kinds of points on there. I don't know, WT, or the order doesn't matter. How about TW? That's a different segment. That's also part of line WR. Okay, so why do you even talk about segments? We have lines, so what's the big deal? Well, segments have something called a measure. Now, a measurement is something that describes anything. Think of your shoes. Okay, you can measure your shoe size. You can also measure the height of your shoes in inches. You can think of measuring income. You can think of measuring all kinds of things. For us, measurements are going to describe things. They're going to describe segments. They'll also describe polygons. They'll describe a lot of different things that we look at. A measure for us is just going to be a positive number that tells us the relative size of something. So for our segment over here, this segment, we started with WR. They might tell us that the measure of WR is, I don't know, say 8 inches. Okay, so to describe that on your diagram, we're just going to put 8 inches. Now if we want to describe using notation, we would say WR equals 8 inches. Alright, so that's slightly different from what I already have listed. This is the segment WR. This is saying, look at the finite part of my line, starting at W going to R, or from the opposite point of view, starting at R and going to W. this is telling me how long that segment is. So this is something that bothers a lot of students, I get it, but whenever we do not have that symbol above, this is talking about the length of that segment. So this is the segment itself. It's describing each point, so each set of positions in this plane from W to R. This is telling us how far apart those things are. One of them is a number, the other one is an actual set of points. So one thing that we will not write WR with a segment equals 8 inches. That doesn't make any sense. It doesn't make any sense because a set of points is just a bunch of positions in the plane. We're never going to say a set of points equals a number, but we might describe how far apart some points are. So a description is different than saying this thing equals. Now I know this confuses people. Think of this. If you were to look at me, I'm about 6 feet tall. And to speak correctly, I should say my height is about 6 feet. Me, myself, I am not equal to 6 feet. I'm more than 6 feet. I'm a person. I have preferences. I like certain things. I also have all kinds of weird quirks. I don't equal just that number 6. However, that number 6 describes one particular aspect of me. So height doesn't equal a person. You should say a person's height is something, but that person has a whole lot more to them. Same with segments. You can describe the length of a segment, but the segment itself is stuck in this plane. We're never going to say a segment equals a number. Okay, so we looked at line segments. We saw the right notation. We looked at measure. Okay, so we would say measure without that little bar equals. How about congruence? What does that mean? So for us, congruence is going to mean same shape, same size. This is going to extend to anything that we talk about the entire year. For now, we're going to focus on segments. So to have congruent segments, well, every segment is basically the same shape because it's part of a line. We're going to focus on the size. So for two segments to be what we say congruent, we say that they have the same size. So for example, let's say I have two segments over here. I don't know, let's say you already used W, T, and R. How about A, B, and C, D? Now, if these two segments, let's say that both of them are, say, 6 feet. Not drawn to scale, obviously. So, those are both 6 feet. Now, those are two different segments. Segments are not going to move unless we perform certain operations later, like at the end of the year. So they're stuck where they're at. So I'm not going to say segment AB equals segment CD. This actually does not make any sense. They do have the same length. They're not the same segments, but their lengths are equal. How do we express that? Well, to express the idea of congruence, we have a symbol for that. We use the equal symbol, and then we put this thing called a tilde above. So this right here would tell us that the segment of AB is congruent to the segment CD. Another way to write that, and I know this is going to take some getting used to, this is the same as saying the length of AB equals the length of CD. When we don't have those bars on top, this is talking about lengths. Lengths are numbers. So numbers can be equal. And in addition to that, numbers we can add things to, we can subtract, multiply, divide, all kinds of things we can do with numbers that we cannot do with segments. So we're going to do a lot of algebra with these segment lengths, and we want to be really careful because these are not variables. I know we're used to letters being variables. These are points in a plane. So point A, point B. The distance between those points, in other words, the length of the segment connecting them. Same for CD. Some ways that you might see that in a diagram. If they want to show you that they're congruent without writing a symbol, they're going to put some marks on there. So let me show you what I mean over here. I'm going to make two other segments. How about DO? Because we're going to, I don't know, do some math problems today, and then I haven't used the Z in a while. So if you want to say that these two segments are congruent, and let's say that we don't even know the lengths, in a diagram you're going to see these little tick marks. So those tick marks are going to mean segment DO is congruent to segment NZ. Another way you could express a similar idea is you could say the length of DO equals the length of NZ. So they're going to put those tick marks on there. Also, they might have a different number of tick marks for different sets of segments. For example, over here, CD is not congruent to DO, but I know it is congruent to AB. So they might put 2 tick marks on CD and 2 on AB. So a different number of tick marks would tell you a different set of congruence. One last thing I want to mention here is I said on that first sort of sheet, the ruler postulate. A postulate for us is something that's just going to be a statement that's obviously true. The ruler postulate tells us that any segment, no matter how big or small, can always be measured. So even if I had a segment that extended from here to, like, I don't know, Mars, well, we can measure that distance. We're not going to measure it with the ruler, obviously. That would take a long time. But the idea is it does have a number we can associate with its length. Also, a segment, I don't know, between 2 tiny cells and a slice of an onion, you can measure that distance. It's going to be really small, but it doesn't matter. You can always find the distance between any 2 points, is what that ruler postulate says. So I'm going to stop here, and then I'll post another video because I don't like to make them too long. It takes forever to upload. We'll talk about betweenness, distance, and then work some examples.